iron and hydroxide, and iron has a +2 oxidation state. FeOH twice. Okay. What about iron 3? OH twice. Okay. What about copper 2? CuOH. Okay, so these are the reaction that usually take place, and these hydroxides are the one which shows colors. Okay. Okay, then what about ammonium salt? Any ammonium salt. Okay, we haven't done this reaction while discussing the properties of, or the chemical properties of alkali, but this is the one of the chemical property of alkali. We did the reaction of acids, right, with metals, with carbonates, with oxide hydroxides, right? We learned those methods. What does it form with what happen when acid reacts with metal? Let's just have a quick review. Plus metal, salt, and good hydrogen. What will happen when acid reacts with alkali? This is a titration, neutralization, salt and water. Okay. Then the third one is the acid with carbonates. Correct. Carbon dioxide, salt, and water. So there is one reaction of alkali that we didn't learn at that time. So it's in the chemical testing as well. Whenever it reacts with ammonium salt, any ammonium salt, that can be ammonium chloride, that can be ammonium sulfate, that can be ammonium nitrate, any ammonium salt. Okay, so it would release the ammonia gas along with water and along with salt. Okay, for example, there is formation of let's discuss sodium hydroxide along with ammonium chloride. What would it form? Good, sodium chloride, H2O, and NH3. Okay, this NH3, the very first identification is it has a very pungent smell. the the smell is like a rotten egg type smell. Okay, the second identification is that we learned that we use the litmus paper to identify it. Okay, what litmus paper would turn into, which litmus paper is going to change color? Again. Okay, we need to learn this. Okay, ammonia form ammonium hydroxide. Okay, so whenever there is hydroxide, it's an alkali, right? So the red litmus paper would turn blue. The end result of alkali is blue. Okay, okay, okay. Let's move to identification of anions. Um, when we talk about chlorine, bromine, iodine, these belong to group number 7. And in general, when we discuss group number 7, we discuss that they show some kind of color, the chlorine, bromine, iodine, right? So they would form some color when they undergo some test. Okay? Okay. Let's talk about the chloride, bromide, iodide. So the color changes, the color would turn darker as they move down. But what is the test? Do you know the test of these halides? Okay. If you know, then please share with us. Okay, we add it later, but what is the first thing that we add? Acid. That is dilute nitric acid. And then we add silver nitrate. So there would be formation of silver chloride, silver bromide, and silver iodide. Okay? Silver halide. In general, I'm writing silver halide. So when I talk about silver chloride, and we discussed that it would form white precipitates. Okay? If we talk about silver bromide, it would give pale yellow, or you can say cream precipitates. Okay, what is meant by precipitates? Since we are using this word quite often, what is meant by precipitates? The solid that forms in the reaction. Correct. Okay, the silver iodide would be the darker one. It would be dark yellow, or you can say yellow precipitates. Okay? Okay. How can we test the carbonate ions? Now, it's an easy one. Carbonate ions. Since carbonate reacts with acid to form carbon dioxide. So, how can we test it? How do we test carbon dioxide? You told me earlier lime water. The lime water would turn milky. So lime water is basically colorless. So when you add in the carbon dioxide, it forms carbonate, which give it a cloudy appearance. Okay, let me write cloudy as well. Okay, the next one is the sulfate ion. So let's say sulfate. How can we tell if something contains the sulfate ion? We are okay, barium chloride. But you're missing one step. We add it later, just like silver nitrate. We add barium chloride later, but what is the first thing that we are going to add? Yeah, we'll add acid and then barium chloride. Okay. So what is going to be produced if we add the barium chloride solution? It will form the white precipitates. Okay. So we add acid and then barium chloride, that will result in the formation of white precipitates. Okay. Um, what are these white precipitates made up of? Wait. Acid plus barium chloride plus sulfate ions. Okay. What are actually white precipitates? As we have discussed, the white precipitates in halide of silver chloride is AgCl, right? The pale yellow precipitates are of silver bromide, and the yellow precipitates are of silver iodide, right? So, what would be like the product here which results in white precipitate? That would be sulfate along with can negative and negative make compounds? No. Can negative ion and negative ion make a compound? No. It must make a compound with a positive one. Which is a positive one? Barium or chloride? Barium. So it would form barium sulfate. Okay? Just focus on the type of ions that are produced. So barium ion and sulfate ion produces barium sulfate, which is a white precipitate. And we have learned this in the solubility table as well, that sulfates are not soluble of barium and calcium, right? We need to use that knowledge as well here. Okay. Then there is one more identification test which is related to water. It's quite easy. There are two basic tests that we use to identify the the presence of water, and those included the water of crystallization. How do you have any idea about the water of crystallization? No. Okay. Whenever it's not about every salt, it's about few salts. When the salts of few, or okay, do you know about the crystal lattice? No idea. Crystal lattice. No. Okay, let me tell you. When whenever for example, sodium chloride is an ionic compound. Okay, so these ionic compounds have a very specific geometry. The negative and positive ions are um, going to be on very specific position. They have proper angles, and then they have proper shapes. Okay, for example, this one. If we talk about sodium chloride, then sodium would be present on specific sites, okay, and chlorine would be present on specific site, right? This is lattice, that during the arrangement of a lattice, the ions would arrange themselves at proper angles or at proper position. Okay, so there are few ionic compounds. When their lattice is being formed, the water molecules get stuck in the lattice. You can say they can stuck into the crystal. So those water molecules are known as water of crystallization. Okay, so one of the most important one is copper sulfate. So I've told you that copper, whenever it's 2, it makes which type of color compounds? Blue. So blue color would be shown only if it has 5 water molecules. Okay, now the number is very specific uh, every salt. If we talk about sodium carbonate, the number of water molecule is 10. Okay, if we talk about copper sulfate, the number is 5. If we talk about the cobalt chloride, because this is also one of the compound which uses the water, that is 2. It can give 2 water molecules. It can have 10 water molecules based on the type of crystal, whatever type of crystal it is. So when we talk about copper sulfate, it has only 5 water molecules. Clear? Okay. You cannot change this number. That is very specific. So if it has 5 water molecules, it would show blue color. Okay. Are you done with the preparation of copper sulfate and the practical skills? No. Okay. So usually we use copper sulfate as a standard for calculating, or for to carry out crystallization, or to make students understand that how crystallization occur. So when the crystals are formed, we first make a saturated solution, then we evaporate the liquid and leave it at a room temperature. That we did in this preparation of salts, right? The method is same. Okay, so because all the water is not evaporated at that time, remember, we leave some water. So that water become, for example, 5 molecules of water become part of copper sulfate, giving it a blue color. But if you evaporate all the water, then it won't be blue. It would turn colorless. since it does not have any water molecule. Okay. The second test is the cobalt chloride. I don't think so that that's in the syllabus, but let's learn it because it's a part of the reversible reaction as well. Cobalt chloride, when its solution, or you can say salts or lattice, is being formed, there are six water molecules that keep stuck in that, and it give it a pink color. Okay, so original color would be blue, and wait if I can find the image. It's one of the tests in biology as well, that how can you test whether water is produced in photosynthesis happening or not. So it's one test over here, over there as well. Okay, this is the color. Let me copy image. Okay, if it has six water molecules, the color is pink. If it has no water molecule, the color is blue. So when all the water molecules are evaporated, it is known as anhydrous. Hydrated and anhydrous. Hydrated, and the second word is anhydrous. Okay, sometimes we use cobalt paper as well. Let me show you the cobalt paper. It's very common paper that we use, cobalt paper. Okay, here we go. This is a paper. It's just like a litmus paper, but it's not a litmus paper, it's a cobalt paper. Whenever you put water drop on it, because it got the water molecule, it starts to turn pink. Okay, it's just like a litmus paper, but it's not a litmus paper. You may feel like that red litmus paper is turning red, blue litmus paper is turning red, but this is not the case. This is actually a cobalt chloride paper. Okay, so these two tests are the one that we usually use for the identification of presence of water, whether it's present or not. Let's discuss some of the questions related to it. Um, okay, I have shared one of the paper with you. Okay, so I have one question related to the flame test. Okay, this is the question. The diagram shows the apparatus for flame test, and you have three compounds, X, Y, and Z. Okay, suggest two reasons why platinum is a suitable metal to use as the wire in the test. It's unreactive. What affect the color of the flame? Correct. Okay. Why should the platinum wire be cleaned between each test? Okay, to remove the molecules. Oh, okay, instead of molecules, let's write substance. Okay, to remove the substance that can change color, that may affect the result. The result. Okay. What is a luminous Bunsen flame not suitable for carrying out the flame test? Because we have mentioned at the start that we have to use the non-luminous one. So why can't we use the Bunsen flame? It won't show the color properly. Um, or we can write the colors are not identifiable. Cannot be identified. That's right, cannot cannot be identified properly because it has different like shades. It has shade of red, yellow, blue. It has different shades. Okay. The next question is, where's the paper? Okay. The test results are given. Let me just minimize it. And you have to tell what do you conclude from these results. Okay, here we go. So we have the three metals X, Y, Z. The X shows the yellow color, Y shows the red color, while the Z show no color. So the possibility of red color is that it might be lithium, right? The possibility for X is that it might be sodium. Okay. But when we reacted with silver nitrate, it formed white precipitate. So white precipitates are of, let's write the chloride. Good. Silver chloride. Um, the red was for lithium. Okay. And when we use the barium chloride, no color is produced over here, but what is produced over here? Barium chloride, white precipitates. Barium sulfate. Right? Okay. So with sodium, aqueous sodium hydroxide, it shows green color. So what it can be? Iron 2. Okay. Here we go with the colors. Here. Right? Iron 2 shows the green color. Okay. This is the possibility that we have written. Maybe it's not correct, but we have written the possibility. Give the name of compound X and compound of Y. So X has sodium and X has chloride. So what it can be? Sodium chloride. Okay. The name is sodium chloride. What would be name of Y? Y has lithium and then barium sulfate. So what would be the name? Lithium sulfate. Okay, identify the cations present in compound Z. Iron, and you have to give the oxidation state. Iron 2. Okay? Okay, describe a chemical test other than heating to show that compound Z contains carbonate ions. Okay, bubble, lime water. And what is the result? Lime water turns cloudy, or another word is milky. Okay, let's move to the next part of it. Oh, wait. The next question is again about, okay, it's about magnesium. The question is, the diagram shows some of the reaction of magnesium. Okay, when magnesium react with dilute HCl, it form hydrogen with something. What is that something? Magnesium plus hydrochloric acid. What does it produce? Magnesium chloride. And what would be formula of that? MgCl2. Magnesium is plus 2, chlorine is minus 1. Okay. Okay, when it react with steam, it form magnesium oxide and hydrogen. When it burns in gas, there is some gas, it produces magnesium oxide. So what is present in that gas that converted into oxide? Oxygen. Okay. When it reacts with dilute acid, now we don't know the name of acid, but it forms magnesium sulfate. What would be that acid? Magnesium sulfate plus hydrogen. What can be that acid? Sulfuric acid. Okay. Now you have to tell the identity of FgNH. First one is magnesium chloride, right? Second one is oxygen, and the last one is sulfuric acid. Okay. Write down the equation between magnesium and steam. So magnesium is Mg plus H2O, right? It forms magnesium oxide plus hydrogen. So what would be formula of magnesium oxide and hydrogen? What is the formula? We have to write this equation. Okay, what is the formula of magnesium oxide and hydrogen? How do we write it chemically? Correct, correct. Plus H2. Mm, okay. The next question is again about the flame test. Okay. Now we have a set of cations. I cannot copy it. Okay. I want you to go through this question and then tell me what are they asking or what are they telling. Okay. Lithium ion, lithium ion, calcium, correct. Okay. So the flame test give no positive result. Okay. Yeah. The pungent smell would be of ammonia gas. And explain why the red litmus paper must be damp before it is used. Ammonia. So I've told you that when we dissolve or when ammonia comes in contact with water, it forms ammonium hydroxide, right? I've told you. So hydroxide means it forms alkaline ions, the hydroxide ions, which makes it alkaline, okay? Or which proves that they're alkaline. So ammonia gas is the one because it has a pungent smell, and we need to dip sorry dip the red litmus paper into water so that when water comes in contact with ammonia, it form hydroxide ions. Then they haven't asked about the result, but we can say that the red litmus paper then turned blue. Okay, so ammonia when come in contact with which gives results for litmus paper. Okay. Identify two cations present in the pale violet solid. Yeah, from the list. So you have told that these are not present. So what is left? One is ammonia for sure because you have told that ammonia gas is produced. What can be the other? Oh, iron 3. The brown precipitates are of iron 3. So it would be ammonia